Nice question. This function is given to you, and they're asking which of the following statements are true. See, all the statements are talking about the zeros of this function. F of x is zero, then this, then what? Okay, so we have to just consider the zero of this function. Okay, so when is the function zero basically? They have already given when x is zero, the function is zero. Now the question is where else? Okay, so now everywhere else the function is defined like that. Okay, when is that zero? X square sine pi by x square. Of course, x square is not zero other than zero, right? Okay, who else? This. Okay, when is this zero? That's what you have to think. When sine of what is zero? Any integer multiple of pi? Okay, sine n pi is zero, you know that? Okay, when n is an integer set. So what do you want here then? You want the argument, which is what? Pi by x square. You want it to be an integer multiple of pi. Then only the second thing should be, this whole thing will be 0. You know that. So what do I do? Now solve it for x. Yeah. So what do you get? X square. Okay. Pi gets cancelled. And you will be left with x square is 1 by n. Okay. Or I will just write x is 1 by root n. Okay. When x is 1 by root n, where n is an integer set, then you will have zeros of this function. Correct? Okay. Let's list them out. Okay. Where are these? So when n is 1, it is 1, 1 by root 2, 1 by root 3. You see, so many zeros. How many? Infinitely many, right? Okay, 1 upon root 5. You keep on going. Like 1 upon root 9 is how much? That's one third. Then 1 upon root 16, that's 1 over 4. Okay, you keep on moving towards the origin. Your number is getting smaller and smaller and smaller. You see that? Okay. Let's see it on the number line where it is. Okay. So 0. This is my 0. Okay, let's 1 over root 1. Okay, so let's write that's the first 0, you know. There's no other 0. There is just this, the first 0. 1 by root 2 will be somewhere here. 1 by root 3. 1 by root 4, that's half, right? So 1 by root 4 is here. Okay, then 1 by root 9, that's one third. Okay, so 1 by root 9 is somewhere here. Okay, so many, infinitely many. I'm just putting a couple of them. There are infinitely many zeros, and all are approaching as you're moving to origin. So around origin you have infinitely many zeros, you see. Yeah. Okay, now let's start answering the questions. Number one, f of x is equal to 0 has infinitely many solutions in this interval. Okay, let's answer that. 1 upon 10 to the power 10. Okay, so maybe somewhere here. 1 upon 10 to the power 10. Can I write that as 10 to the power 20 under root? Yeah, that is same as 1 upon 10 to the power 10. Okay, so how many zeros are between this point and infinity? Okay, this is infinity. You keep on and on and on. You can count, right? See, you're starting with 1 upon root 1, then till 1 10 to the power 20. So there are 10 to the power 20 zeros in this interval. Okay, I can count. Yes, it is a huge number, but not infinitely, right? So this is wrong. Okay. Okay, let's go to the second option. F of x has no zeros, no solutions in this interval. Okay, 1 upon pi. Okay, how much is 1 upon pi? Let's try comparing with 3 because that's the closest one, right? So pi is greater than 3, correct? Okay, so that means 1 upon pi should be lesser than 1 upon 3. Yeah. Okay, so 1 upon 3 is this 1 over root 9, correct? Okay, so 1 by pi is somewhere here. 1 by pi is somewhere here. Now 1 upon pi to infinity. Can you see? I can count the zeros. Okay, there are some zeros, right? I don't need to count, but there are some. Okay, so again, this is wrong. Good. Go to C. This f of x is equal to 0. A set of solutions and of f of x is equal to 0 in the interval is finite. Again, wrong. Because around 0, just now we said, right, the solution will keep on pouring. Okay, near in the neighborhood there will be so many, infinitely many. Okay, because number will not end, right? You have written 1 upon root 10 to the power 20, then you can write 1 upon under root 10 to the power 20 plus 1. Keep on adding, keep on adding. All the zeros will be here. Yes. Okay, so there are again infinitely many. Okay, so this is again wrong. So I hope last one should be correct, right? Okay, f of x is equal to 0 has more than 25 solutions in this interval. Okay, so let's try inserting some known interval between them. Okay, so this is the interval. Okay, pi we already said. Okay, you said that. Okay, 1 by 4, let's write. Okay, so this is 1 by 4 because okay, pi is lesser than 4. Okay, so 1 by pi should be greater than 1 by 4. Okay, so of course this I can have. And then pi square. Okay, let's use 3 now. Okay, 3 is lesser than pi. Okay, 3 square is also lesser than pi square. So 1 over 3 square will be greater than 1 over pi square. Okay, so I can write that 1 upon 3 square. Okay, so it's like this. Okay, I want this interval, right? 1 upon pi square and 1 over pi. Okay, what I'm trying to do is I'm trying to insert an interval between that. Okay, so I'm having 1 over 3 square. Okay, this point is 1 over 3 square and this point is 1 over 4. Okay, now can you see between that how many zeros you have? 1 upon 3 square, that's 1 over 9. Can I write 1 upon root 81? Yeah, and I can write 1 upon 4 as 1 upon 16. See, 1 upon root 16 is a 0, 1 upon root 17 is a 0, 1 upon root 18 is a 0. Keep on counting till here. Of course, more than 25, right? Way more than 25. So, of course, this has more than 25 solutions. Okay, so this is correct. Hope you understand. See you with another one.